Okay, so I think I've already mentioned this aspect before. In one of my tutorials, I was mentioning how you will be able to find distance from velocity function and also velocity from the acceleration function. And I made mention to the fact that if you studied your calculus 1 well, that is differentiation. You can see that if you are being given a distance function, let's say that your distance function is being represented by s of t, and you are being asked to calculate for the velocity. What you need to do is just take the first derivative of the distance function, and you are going to get x prime of t, and that x prime of t is equal to v of t, and this is the same as the velocity at time t. Same thing applies to acceleration. When you are being given a distance function and they ask you to find the acceleration, what you can do is differentiate the distance function twice, because when you differentiate the distance function once, it gives you the velocity as indicated up here, and then when you differentiate the velocity again, you are going to get acceleration. So in this case, when I differentiate the distance function twice, it's going to give me the first differential of the velocity that I got up there, and then from there I can see I've gotten my acceleration function. So this is equal to the acceleration at time t. So since you have understand this concept, then the reverse becomes easier. Let's look at something here. We always say that integration is a reverse of differentiation. So now, in differentiation, if we are looking for velocity and you are being given a distance function, you differentiate to get the velocity. If you are being given the velocity and you want the acceleration function, you differentiate the velocity to get that. And even if a distance function, you differentiate the distance function twice to get the acceleration. So what is the vice versa? When I say the vice versa is when you are moving from the biggest to the smallest. So currently, let's assume that you have been given the acceleration function, or you have been given the velocity function, and you are being asked to find the distance function. How are you going to approach this? So the solution is simple. The solution is to integrate whatever you have to bring it down. So this is the trend. From distance to velocity to acceleration, it's differentiation. And from, this is the other way around. From acceleration to velocity to distance is also integration. Take note. And one thing that you have to take note is that always keep in mind that if you are not being given the limit to use in your question, at the end of the day, you are going to introduce the arbitrary constant of integration, which can be the c or the k, depending on which letter to use in order not to confuse you. So in this case, since we are not using c anywhere in our symbols that we are using over here, it means that we can use the letter c as our arbitrary constant of integration. So now that we understand that when we are moving from distance to velocity to acceleration is differentiation, and we are moving from acceleration to velocity to distance integration, let's look sharp and solve some couple of examples. So before we go to some examples, let's look at something here. Now, the first examples that we want to tackle, it's coming from a physical science in a distance, which is about distance. So let's solve this question. This is a simple question that can aid in, like, it can help you understand whatever concept I'm trying to actually explain here. So suppose that you have a v of t. That v of t, I think the function didn't come, so I need to actually write a function here. The v of t here has a function of 5t power 4. The v of t have a function of 5t power 4. And x of 0, I think the whole question didn't come, so pardon me for that. X of 0 is equal to 9. We are being asked that we should, okay, I think the x of 0 came here, and then v of t, I think it came down here, but the power didn't come, right? So x of 0 is 9. And then the question is, we should find s of t. As it has been stated here, find s of t. So it also says that we should assume that s of t is in feet and v of t is in feet per second. It's in feet per second. So now you have v of t. Your v of t is being given as 5t power 4. As I said, now we are moving from the biggest to the smallest, and therefore we are using what? Integration. So taking integral of both sides, we are going to get s of t, because when we integrate a velocity function, we are supposed to get a distance function. And therefore, integrating 5t power 4, we are going to get 5t power 4 plus 1 over 4 plus 1, and plus our c, which is our arbitrary constant of integration. So at the end of the day, we are going to get s of t equal to t power 5 plus c. And remember that in the question, we were told that x of 0 is equal to 9. That means that at time t equal to 0, the distance is 9. And therefore, when we substitute x of 0, which is equal to 0 power 5 plus c, and where our x of 0 is equal to what? 9, we can say that 9 equal to 0 power 5 plus c, and therefore our c equal to 9. So what we need to do is to come back and plug it into the original function to get our particular solution of the distance function. So in plugging it back, we are going to get s of t to be equal to 5t power 5 plus c. And now the c becomes s of t equal to t power 5 plus 9. So this is our final answer. When you are being given a velocity function and the acceleration function, and you are being asked to find the distance, integrate it twice. When it's velocity, integrate it once. So this is one example. I hope you have now understand how you go about this type of question when you are being given a velocity function. I'll solve some couple of examples with you where you'll be given acceleration function and many more, right? So stay tuned and See you in my next video.